when he really needs to be engineering from the vacuum.
Right, but you're not doing this for the chat group, are you? You're doing this to try and get a bigger business or whatever that's going to...
I'm doing this for general mankind.
Okay.
To get out the knowledge to general mankind out.
But you're hoping, I would imagine, that somebody responsible is going to take this and change the way we do
and do something with it
more
because
efficiently and
exactly.
Yeah.
We're not here to insult any engineers or say your theory doesn't work, because their theory does work.
Mm-hmm.
You know, I've engineered my entire life with their theory from the textbook, and I can tell you it can make the power meter spin. I wanted to look at the other end.
Yeah.
I wanted to look at the end that Tom Bearden was talking about. What is Tom writing here? Is Tom wasting his time writing? That was my question. No, he's not. This stuff actually does work exactly the way Tom Bearden says it works. I'm not here to insult engineers, once again. I'm just here to try to say, hey, gee guys, let's have a look at this. What's this doing that we're missing? Can't we engineer this into our circuit some way to make my transistor radio last like 40 hours more or 100 hours more? Or gee, when that battery's dead, can I just take the one out of here and put it over here? No, you've got nobody that's willing to stop their normal routine and really look what's going on around them.
Yeah.
They want to go down to the local stand and get some cheese for free. The internet is about freedom of speech. Sharing ideas back and forth. But you can see that it's been totally infiltrated by naysayers and skeptics and people that want to bring about the whole total socialization of this without any of the benefits of it. You got to be able to grow your own food in the future, pump your own water, you know, and make sure that when you're pumping that water, that another battery is being recharged at the same time you're taking your bath. You know, we're trying to do this currentless. We're not trying to use very much current doing this at all. In fact, the absence of the current, the more the vacuum adds energy. The more current you put into the circuit, the less the vacuum energy comes in. This is about the change in society. Can mankind become efficient? That's what we need to know. So this is sort of a little test. Here's the information. What can you do with the information? Some people are gaining knowledge and learning. Others, it's just a hobby. It's frightening. It's very frightening to know that we don't have these energy sources and that we're running out of fuel and oil, supposedly. I don't think so, but, you know, and that we're warming up the earth, that's poppycock. These cycles on the earth have been going on for thousands of years. It's all controlled by the sun out there. It's all about magnetic fields and what the magnetic fields do. On one side you see the ice caps melting, on the other side you see the ice caps growing. Who's on first here? That's what I want to know, is who's on first? Does it work or doesn't it work? Can we do something with it, or do we have to throw it aside and start over? That's my question. I've done the best I could do I've given them the most information I could give, from all my years of research. And now it's just, I leave it up to them. Either take the leap or just face the future. That's all you're getting from me, Tony.
That's very
Right.
sweet.
Very good, John.
You're probably going to put it in there too, aren't you?
Some of it, at least.
I'm going to cut it and mangle it so badly that.
He's going to make you say something else.
Yeah.
He's going to be globalist or global warmer.
No, I mean, you got it right there in a nutshell.
Yeah.
You have the whole thing in a nutshell there. You have this right at your fingertips. If you don't choose, and don't complain about the price. I spent 40, almost 50 years spending my money to figure it out. You're getting a deal if I say $75 for the book.
Yeah.
Think about the guy that's filming. He hasn't asked for a dime. What's going on here? Today you have access to all this information and you have the internet. But they're abusing the internet so bad that they're just going to take it away. Then you're not going to have any information. You better hope that you copied all the stuff off on a piece of paper and that you have it so you can do it. I think we've done our best.
Yeah.
Yeah, I think so too.
And there's more. We're growing, and we're sharing a little bit more each time. We're not hiding anything. There's nothing in here. You don't see any black boxes on top of anything. You can see the circuits right in front of you. You can see the wires.
Oh, clear.
See, Rick's got it in a clear plastic box. Okay, there's nothing hidden here. We don't have to hide anything because we're not frauds about anything that we're doing.
And the thing about these kits is you build them yourself,
Mm-hmm.
or you can make it yourself. You can go to the store and buy it, buy the parts wherever you want to buy them, and it'll work.
On the internet groups that you participate in and that you run, Rick, about how many people are in these groups?
Well, we started off with the Bedini Monopole 3 group, or Bedini Monopole group, and we had hundreds of people first year, and then that eventually we made into an advanced group, and now we have a similar group called Bedini Monopole 3, and there is maybe 700, 800 people on that now. It just grows every day. More people join that group. And most of them don't participate, but a lot of them do, and they replicate their version of these. When I say their version, they get their parts. They get their parts from wherever. They build their motor whatever size, and then they post the results. So we have people all over the world. And then, of course, the group is open to the public, so everyone can view it without even joining the group. So I estimate there's thousands of people watching that. And what we're trying to do there is give the basic circuit without all the advanced stuff, so that everybody can focus in on that, understand it, which it sort of makes it easier on me. I don't have to answer all these questions all over the place about every different circuit. We've got to start off the basics. And once you understand, what we want to do there is show two different things. That you can restore ruined batteries or desulfate batteries. And then we also want to show how there's two energies, as John's been talking about. Once you get to that point of really understanding there are really two energies and how they work, then you'll naturally know how to move on. But most people just have this gold rush fever, right? John said,
Yeah.
where they're
Gold fever.
Gold fever. They're just impassioned. They want free energy now, and they can't listen to any instructions. So they'll come in, they'll see the basic circuit, and they'll say, which is just this right here, you know, and they'll say, well, I can improve upon that. You know, it's a transistor and a diode and a resistor, and we had another diode off here to go to the charging battery.
So that's the basic circuit.
So that's the basic circuit with an inductor, with the coil. You know, and then the motor. Well, they want to do this and that and say, well, this is how you improve it. And they spend all their time trying to figure out
Well,
how to
one thing
improve
that's very important here, Rick, is it's already as simple as it can get.
Yeah. So why?
There's nothing difficult about this at all. You just follow directions, and it'll charge your battery.
Yeah.
You don't have to be an Einstein to make this. Einstein doesn't work here. This is simplicity. The simplest form. This is the easiest way to show what the energy is. We couldn't make it any more simple. But most people are looking for sophistication. As I said, there's an old saying from Paraguay. I put all the gold, all the silver around the wheel for the eye of the ignorant. So he misses the whole concept of the simplicity.
Yeah.
Who made that statement?
Paraguay is 1269 AD.
And he built
He built a permanent magnet motor while he was at war.
in 1269.
Yeah, and he said, he wrote it in a thesis. He said, I've dressed up everything so that your eye is focused on this blue capacitor or this gold spot over here, and you miss the whole workings of the motor. And he called it the eye of the ignorant.
And see, this is the
It was
thing.
quite profound because nobody ever duplicated it except for Lee Bowman.
So what I've observed over the last 3 years is John has laid it out again and again, the basic points, and people just miss it. They just go off here and there and make these demands and what have you.
Well, I'm not politically correct, Rick. You know, my I's aren't dotted all the time, and the T's aren't crossed, and every once in a while something's misspelled or the punctuation mark's in the wrong spot. But you know what? If you don't understand street language, what are you doing here? You've heard the saying, book smart, life dumb.
Mm-hmm.
But there's all sorts of people, engineers all over the world are replicating these. Not everybody posts their results. You know, they send things privately on emails and that. But you have people who are, you know, kids building these for science fairs as the original schoolgirl, 10 years old. Or you have people who are, you know, the most advanced engineers. In fact, I brought this exact motor around with me in a box around the whole country this year, this winter, and I showed this on campuses all across the country, and I met people who were PhDs to, you know, your basic college student, and they were fascinated. As you know, we discussed that. So a lot of these people have joined the groups and you know, replicated these things. So there are a fair number of people who have moved on from the basics, but this is all that's necessary is to know what the energy is, as John's describing the boards there, and
It's sort of a primordial energy.
yeah,
It's like before electricity.
Precursor.
it's like
Precursor.
earth currents and all
Yeah.
that.
You know, and this kind of energy likes to see a high impedance. It absolutely does everything opposite
Yeah,
of what the conventional energy does.
yeah,
And as Tom Beard points it out very precisely, that what we're looking at right there that's coming out of the wall is just a waste product.
yeah. That's what these are measuring waste.
When you talk about negative energy, is that on a par with positive energy, and that both subsets of precursor energy, or is negative energy essentially precursor
It's
energy?
precursor.
So negative energy is
Yeah,
essentially
it
precursor.
has to come through the vacuum before it can become positive at all. You know, this is all conversion.
So radiant is the same as precursor, is the same as negative.
It's an energy that's been here since the dinosaurs.
Okay.
And we're just figuring out that energy flows without any current.
You can't really measure it, but it's there, and the battery's charging when it shouldn't be.
Mm-hmm.
Now, you can put meters on it, and they show something, but they don't correspond to the actual state of charge of the battery. And that's one of the major things that we're trying to look at on these lists, is what is charging your battery? It shouldn't be charging anyway, and it doesn't correspond. If you put a meter in line with it, no matter how you look at it, it's never going to show that it should be charging at that rate.
Yeah, but you might point out too, like if you get engineers who only know how to put a current meter in one,
Yeah.
and they're saying, well, there's no current here, so it couldn't possibly be
So
charging.
they don't even look at the results. They're not willing to charge up the battery and load it down. Charge it up, load it down, and see the actual work that comes out of that battery. And, they look at, like John says, they look at the meters and they say, well, it's not impressive. But what the impressive thing is to see what the actual energy comes out of this battery. Not to mention, it's making that battery better over time as well. So,
Very good.
well, I was just going to show here then a little bit more. If you want to come here and see it, as I'm going to start this up again. And just to show you what kind of power, I mean, you can watch the voltmeter, but watch what happens. This capacitor is going to fill up and, very fast and discharge very fast, but you can see the neon bulb.
Where am I supposed to be looking?
Well, you can look at either one of them. So the neon bulb is showing you. So that's how much power is going into that charging battery.
High potential.
High potential. So now what I'm going to do, you got to do it pretty fast, otherwise it's going to blow up this capacitor. So now what I'm going to do is show these batteries and swap these batteries around. Which on that one I have the switches that could just do that. But here we're just going to swap them around. So you can see, the battery can be swapped around and recharged. And the other one powers it. That was just
the capacitor makes it possible, it converts the energy to a positive energy that the battery wants to see. So now it's more like as if you took that battery and you used a wall charger to charge it.
Yeah.
And that makes it possible now to switch the two batteries.
Yeah.
We're taking it out of the negative time domain and bringing it to the positive time domain.
Yeah. So let's start it up again.
So you've just switched batteries here.
Yeah. This is one that's slightly down. See, when you do that with the capacitor,
When you
can
spark it, you damage.
Well, what happens is it can, go back into the transistor and ruin the points. But so that's why we have the neon bulb on there, so that there is some protection. Which many times I put a resistor in series with that, so it
Let's
doesn't
see,
blow.
take the charging battery out.
Oops, that's not one.
It's quite a...
So I wouldn't want to leave that off for very long.
Yeah.
Otherwise, this is only a 200 volt capacitor, and that just go beyond the 200 volts. right? There's no transformer in this. So how do you get a higher voltage than the battery that's powering the system? That's what people can't understand. This capacitor can actually be fully charged and actually explode. I've seen that. So you got to be careful with these systems. You got to know what you're doing. That's
So
why.
go ahead and run the tape motor.
Okay, so we're going to disconnect this and.
So they can watch it there, and this will be.
Oh. Now what's going on here? The batteries. There's nothing powering it.
Yeah, there's nothing powering
What?
it.
Look at this.
Right. There's nothing powering it.
Now, this doesn't happen very often. This particular motor has been very strange. As I said, it was running all day yesterday and most of the day today.
It's basically running on its own capacitor discharge.
It's running on the capacitor discharge, but there's one wire here. One
Right.
wire is only connected to this
Right.
battery.
So you got a motor running just off one wire.
Oh no, wait a second, sorry. Huh. Okay. Anyway, what I wanted to say was that these batteries, when I brought them in this morning, they were more discharged than they are now. You know what happened was, I think I switched my wires in the wrong position. Hold on a second.
That's possible with all these wires.
Yeah, this is why it's such a mess here. Sorry. Anyway. Where's this? Okay, that's what it was. This one is here. Okay, what we're going to do is run, let's just get rid of this one. We're going to run this one right here off of these little batteries. I think John was calling this the chirper motor. Okay, there we go. Yeah, that's the problem. I had my wires,
Crossed.
yeah, mixed up. But it was still interesting what was happening anyway. I think that should be still fine for the video. Because, yeah, it wasn't running nearly as fast. It was like, what's going on here? That's why, that's why I added that those switches in there. Because people always cross their wires. They get them backwards and just two flips of the switch, Okay, what we did is we removed that fan, and now we're going to go back to the original
Tape.
tape motor. You can see, again, if you let the batteries rest, they'll come back. And when I brought these batteries in this morning, they were discharged more than they are now. And I ran, I've been using these all day and swapping them back and forth. Okay, so this is the tape motor fan again. It is a brushless motor in which there's a circle magnet here on the top, and on these brushless motors there's north-south, north-south, either 4 or 8 poles around here, and then there's individual coils here. In fact, here's what it looks like inside.
Ironless.
Ironless. No, well,
Ironless coils.
right here, yeah, this one. So now what we're going to do is look at, we got the scope hooked up. And this one you need to give it a good little push. You can see the charging rate, the discharging rate. And it's going to go through some phases here. It's going to go whoom. And this one draws a lot of power because this is pushing as it gets up to speed. So it's going to take a little bit to get all the way up to the maximum RPM. And we're not putting any load on it, so it's going to go faster.
Just to reiterate, Rick, which is the driving signal battery, and which is the battery you're charging, and which are the corresponding meters?
This one is powering. I got them in reverse now from what it was before. This one's powering the system with the clips, and this one's charging.
Okay.
Now here's the difference. This one does not have the capacitor dump on it.
This one here is powered. And this one's in charge. Because if you take this off, see?
Oh, no, I'm sorry. You're right. Yeah, you got it. I have it backwards. You're right. So, yeah, you can see the neon bulbs come on here.
And the neon bulbs indicate what?
You're protecting the transistor.
Indicates the radiant energy in the system.
Now, these ones also have resistors in series with the neon bulbs.
Keep them from popping.
Because, as you can see, this one can be run at 24 volts.
So, because the radiant is essentially a gas, the neon is one of the only ways you've been able to find to indicate...
To detect it.
To detect it.
Yeah, which in the other DVD you can see
Right.
John showing that with one wire, and I've done the same experiments. So, taking it off, it's got nowhere to go, in a sense. And so you can see the scope shot. Now,
Let me get the scope shot here.
Well, one way to show this, Tony, the conversion. The battery's doing the converting here. But we can capture the radiant. Notice that this capacitor is very small, but look at the voltage.
yeah, that's the one we want to look at.
Okay, so now...
Over 20 volts.
What's here?
You filled up that gap real good.
Yeah.
Let me do it again. Basically, when you use a capacitor dump system, you dump it across this battery that way. See, so this is charged, right? So depending which way it's charged, right, you dump it across the battery like that. And the battery bounces up real quick.
So we got 100 volt divisions here.
Yeah.
And look how high we're going here.
So we can see here that we can constantly keep doing this.
So that would pop those capacitors if we left it there, because it's over 300
right,
volts.
it's over 300 volts, and we don't want to do that. And we want to catch that. See?
Yeah.
And then we'll just send it to the battery because it's actually a better place for it to go. And then right away the battery starts charging.
And you can hear the motor change too.
Well, because we're sucking all the energy out and delivering it to the net.
Yeah. So the 1266 is the one you're charging.
Yep.
Yeah. So you put more load on the motor and the charging goes up.
Yep, in some situations, yeah. Now this one, like I said, it's a different system because it doesn't have the capacitor dump on it. But yeah, it's going to take less energy.
What do we got on the
Now we can change the speed on this. Okay, now what I did was, let's change divisions so you can see that.
So what are you doing at the moment?
No, I'm just looking at the oscilloscope. So yeah, now this one we won't want to rotate around because we don't have the capacitor discharge. So it's a different kind of charge. And, each person who experiments needs to learn, the difference. So this is sort of, and so if we want to change the speed on this, we would change those resistors.
Very good.
Wait, you need to open the flow.
Need what? Need what?
When you're done with it, you have to go.
Oh, yeah, but I'm behind the camera.
Is that what he does in his movie?
Yeah, right? At the very end of the movie, he goes,
He always does that. Whenever I talk to him.
So I only watched the first 2 or 3 minutes and I knew it was rubbish. So.
all this gets edited out, all right?
Yeah.
We wouldn't want to have that.
We want to sell DVDs, not to dissuade people from. Okay, is that it, Rick?
That's it.
Okay, great, good job.